Hi, Mrs McTaggart here. In this video we're looking at the higher maths topic of quadratic theory, and we're looking at quadratic inequalities. Now, this is quite an important little lesson. It's got a really important skill in it, and you will use quadratic inequalities quite a few times. It also crops up a wee bit in some differentiation questions towards the end, so just watch out for them. And as long as you can factorise and draw very basic quadratics, then this is not too bad. So let's have a look. So here are the steps. Basically, what you've got is you're used to solving this trinomial equal to 0, and you would put it into two brackets. You get two values of x, and then you'd say, right, that's my root, so you'd probably stop there. We're going to do something very similar, but what they're actually looking for here is they're looking for when your trinomial is greater than 0. So here are the steps we do. First of all, we solve equal to 0. So we put this question equal to 0 to find what the roots of the quadratic would be. So step 1, right? So we do x squared plus 3x minus 10 equals 0. When you solve that, two brackets, you're looking for numbers that multiply to 10 and add to 3. So 5 and 2 work, so it's going to be plus 5 and minus 2. When you solve each of those two brackets, you get x equals minus 5, and you get x equals 2. Now the quadratic x squared is a smiley face quadratic, so we're going to draw this here. So we've got a smiley face quadratic, and your roots are at minus 5 and 2. Now we are looking for, if I take you back to the beginning, we are looking for when this is greater than 0. So on your picture, where is that graph bigger than 0? Well, it's bigger than 0 here and here. And in class I would do some wee wiggly lines, or I would change my pen colour to show that. So that's the bits of the graph I'm interested in. So what values of x are those bits of the graphs? So that first half, this bit here, is when x is before minus 5. Now to write that, you write it as x is less than minus 5. And then the second bit of the graph, well, that's anything after the number 2. So you write that as x is greater than 2. And notice, look at my wee diagram, I drew two wee bits in red, so I've got two completely separate answers. So this will always give us a positive value when your numbers are less than minus 5 and greater than 2. Anything in between is when it's actually less than 0, all right? But let's have a look at the second one. So sorry, I should have just numbered what I did on the steps. So step 1 was getting the roots. Step 2 was my little drawing. And step 3 was writing down my solution from the graph. Okay, so eagle-eyed people might spot that this looks exactly the same question, but this time I'm looking for when it's less than 0. So I'm just going to go back and draw it again. So we already know this is a smiley face that cuts at minus 5 and 2. I am looking for when this is less than 0. So with my red pen, what I'm looking for is this bit here, when my graph is under 0. Now, it actually says less than or equal, so I have to actually include my roots in this answer. So any value between minus 5 and 2, can you see from the picture, is when I'm going to have a negative value on the graph. So to write that, the between part is a bit tricky. You'll have seen this before whenever you're doing trig equations and it's got the bit at the side where x is between 0 and 360. Very similar. So you have to put the x between the two numbers. So it's going to be between the minus 5 and the 2, and then we put some arrows in. Now if in doubt, my class sometimes go, which way do the arrows go? And I always say, what would Beyonce do? And there's a well-known Beyonce song where she goes to the left, to the left. So that's when I say to my class, what would Beyonce do? And it reminds pupils that arrows point to the left. So it's just one of those wee nice maths tricks. So the arrows point to the left. So normally you would say, right, x is between minus 5 and between 2. But because it said less than or equal to, you have to include the equal to signs on those, because we can include the number 2 and we can include the number minus 5 here. Okay, so same question, but look how your answer differs based on what is at the very end there. Just a wee arrow of a difference. Let's try another one. So this one we have to solve this trinomial greater than or equal to 0. Now I don't know about you, but I think solving negative quadratics is pretty difficult. So what we're going to do is we're going to imagine we're taking everything to the other side. So this would become positive x squared, positive 8x, and positive 12. So I'm going to solve that equal to 0. Right, numbers that multiply to 12 and add to 8 are 6 and 2. So x plus 6, x plus 2. Now when you solve that, that would give you x equals negative 6 and x equals negative 2. Right, go back to your original question though, not back to the way I did the factorising. going back to the original question, this was a negative x squared. So what I've got this time is I've got a sad face quadratic. And my roots are at -6 and -2. Now the question wanted this one to be greater than or equal to 0. So I'm looking for this bit here. When is my graph above 0? So it's above 0, anything between -6 and 2. So I'd have -6, x and 2. Remember, arrows go to the left. So that would be x is between -6 and 2. But again, it wants it greater than or equal to 0. So we have to include the -6 and the 2. So put in your equal signs on your arrows. Okay, so my next question says solve 2x squared plus 6x is greater than 0. So they're not always trinomials. This one is a common factor question. So common factor here is 2x. So you do 2x bracket. That leaves you with x plus 3. And remember, step 1 is putting equal to 0 to go and find where the roots are. Breaking that up, 2x equals 0. Well, that means x is 0. And x plus 3, well, that means x is -3. Now, if you go back, the original question is a positive 2x squared, so we've got a smiley face quadratic, and it's cutting at 0. Oh, I've done that the wrong way. It's cutting at 0 and -3, so -3 first, and then 0 that way. Now, this one wants when your graph is bigger than 0, so it's these two bits here, right? So when it's bigger than 0, two separate bits on my picture, so two separate bits to my answer. So it's greater than 0, anything before -3, so x is less than -3, and anything after 0, so when x is bigger than 0. So remember, if you've got two colour any bits, it means you've got two separate answers. And then that's me done. If you've got the TJ textbook, I would recommend you go do some of page 61 in question 2. I hope that's made it okay for you. I remember, to be honest, when I was at school, I didn't understand what I was doing here. And I realised when it came to teaching it, it was all about drawing the diagrams. And those pupils who try and skip doing the diagrams and have guesswork, well, you're not going to get it right. So it has to be all about smiley face, sad face. And get your coloured pen out, okay? Thanks for watching.